In example 5 part C, we have the definite integral from -2 to 2 of the square root of 4 minus x squared dx. Now, you may or may not recognize this as a circle equation, or at least maybe the equation of an ellipse. But if you take the equation x squared plus y squared equals r squared. That's the equation of a circle centered at the origin. If you substitute 2 for r, we get x squared plus y squared equals 4. And if you solve this for y, you get y equals plus or minus the square root of 4 minus x squared. Now, you can plot a circle on your graphing calculator. Even though a circle is not a function, it fails the vertical line test. If you split it up into two functions, positive square root of 4 minus x squared, which is the upper semicircle, and negative square root of 4 minus x squared, which is the bottom semicircle. So you put the positive one in for y1, the negative for y2, and you can actually graph a circle on your graphing calculator, even though your calculator will only graph a function. That's a nice little workaround. Now, I say all of this just to make the point that this is recognizable as an upper semicircle with radius 2, the square root of 4. And if you didn't see that, here's a little bit of explanation for it. Now, what I want to do at this point is to go ahead and graph this upper semicircle. And so let me lay in the output from my graphing calculator, and I need to talk a little bit about that also. So here is my graph of the positive square root of 4 minus x squared. And as you can see, my x min is -2 and my my x max is +2. So I'm on the interval from -2 to +2. Now you may have noticed when you graphed your semicircle on your calculator that it may look like an ellipse, and mine actually looks like a semicircle. And so why is it that circles look squashed on the calculator? Well, it's because the aspect ratio of a graphing calculator is 3 to 2. That means that each one of these units on the y-axis is only 2/3 the total length of one on the x-axis. In other words, you could mark this off as 3 units, and this would be 2 of the same units. So it's this rectangular aspect ratio that squashes our circles and makes them look like ellipses. How did I make mine look like a circle? Well, I cheated a little bit. I made my x min -2. I made my x max +2. I made my y max +2, but I made my y min -2/3. And so that allowed me to compensate for that aspect ratio just to make a nice looking graph. So, oh, by the way, let me get rid of this, move my graph up, and let's actually do the integral. All right, so we have the definite integral from -2 to 2 of the square root of 4 minus x squared dx. And that's going to be equal to 1/2 the area pi r squared, where r is my radius. So pi times 2 squared would be the area of the entire circle, and since I want the semicircle, I'm taking half of that. So this is going to be 1/2 times 4 pi, which is 2 pi, and that is my solution.